Go.
Welcome to geometry class. You guys thought you were going to get away with it, didn't you? Thought you were going to get out of having Pastor Dom, your favorite teacher, teach geometry, but I will find ways. And this is the way I'm coming to get you. I'm invading your homes, invading your social media, and we are going to learn geometry. So I hope everybody's doing well. We're going to open up with a word of prayer. We're going to get in, do a little bit of review. Then we're going to get into our new material this morning. All right, so let's pray, and then we'll get started. Our Heavenly Father, thank you for this time. Give us wisdom as we begin our geometry class. Illuminate each student. I pray that they work hard and diligent. In Jesus' name, amen. When we last left off on Friday, we looked at the geometric mean. The geometric mean is the two numbers that are inside the proportion. And so we looked at, on Friday, we saw that 2 over 4 is equal to 4 over 8. The 4s are what is considered the geometric mean. And when we're referencing right triangles, the geometric mean will be the altitude of a right triangle. So this is kind of what we looked at on Friday. Today we're going to pick up on page number 8 in your material. Page number 8 is we're looking at similar right triangles. Similar right triangles. So if you turn your books to page number 8, come on, Chris K, wake up. Let's go. Bobby, get your feet off the table. Let's get started here. 3 similar right triangles are formed when an altitude is drawn from the right angle to the hypotenuse. Since the altitude is perpendicular to the hypotenuse, the altitudes form the right angles for 2 of the similar triangles. And so if you look up on the board here, we have triangle ACB. Okay, we have a right triangle ACB. Once I draw the altitude, it's perpendicular to the hypotenuse. Now remember, the hypotenuse is opposite of the right angle. So AB is the hypotenuse, right? And so CD is the altitude. So once we draw that altitude here, we have similar triangles. And we actually have 3 similar triangles. So we have the original triangle ACB. And then if I were to isolate this triangle here, you'll see it up on the board here. We have triangle ACD. And then thirdly, we have the triangle in this quadrant here. We call this triangle CDB. Those are all similar triangles, which leads us to Theorem 92. So Theorem 92 is a highlight. Make sure you understand, memorize Theorem 92. It says this. Read it with me. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed, Gabe, finish it. Good. Are similar to the right triangles and to each other. So if the altitude is drawn to the hypotenuse, so we have an altitude, it's drawn to the hypotenuse, okay? Then the 2 triangles formed are similar to each other and to the right triangle. So quickly, there's 3 triangles here, okay? So if we draw an altitude that's perpendicular to the hypotenuse, the 2 triangles that are formed, so triangle ACD, triangle CDB, are similar to the original triangle, which is triangle ACB. That is Theorem 92. So you want to make sure that you understand that. So once we draw the altitude to the hypotenuse of the right triangle, we have 3 triangles formed. The 2 triangles that are formed by drawing the altitude become similar to the original right triangle. All right, so let's turn to page number 9. Page number 9. We're going to build on this now with similar triangles. Okay, so we just stated they're similar. Class, you remember what similar is? Hannah, what is similar triangle? Good, great job. Similar triangles are triangles that are the same size and same shape. Gianna, I know you're paying attention, G. What is the characteristics of similar triangles? Good, excellent. So the 2 characteristics of similar triangles is they have to have the corresponding sides proportional and the corresponding angles congruent. So we're starting off and saying that these triangles are similar. So we want to prove the sides are proportional. So page number 9, we're going to read up beginning the top paragraph. It says this. If the second and third terms of a proportion are equal, okay, the second and third terms of a proportion, that would be considered the geometric mean, all right? The second and third proportions. If they are equal, they are the geometric mean of the proportion. Now, the length of the altitude drawn to the hypotenuse of a right triangle forms the geometric mean of a proportion. The first term of the proportion is the length of the hypotenuse on one side of the altitude, and the fourth term is the length of the hypotenuse on the other side of the altitude. Now, I know you're asking, what in the world am I talking about? All right, so let's illustrate that quickly. All right, we have triangle here. Triangle A, C, B. All right, we have our altitude, CD. Okay? All right, so again, we have those three similar triangles that are formed. We have the original triangle, ACB. Then we have the second triangle, ACD. And then the second triangle, CDB, the third triangle. All right, so they're the three triangles that are formed. Now, here's what this is saying. The length of the altitude drawn to the hypotenuse of a right triangle forms the geometric mean. Okay, so if we were going to set up a proportion class, understand that the altitude is the geometric mean. Okay? The altitude is geometric mean of the proportion. Now, what goes in the first term and what goes in the fourth term? So that's what I want to show you quickly based on this altitude that is drawn. So the first term of the proportion is the length of the hypotenuse on one side of the altitude. Okay, again, here's the hypotenuse. Okay, what is the length of the hypotenuse on one side of the altitude? So here's the first term. Okay, so let's say the left side of the altitude, the right side of the altitude. So what's the left side of the altitude? What segment? Liam, come on Liam, pay attention. Get your head up out of your arms. There we go, good job. All right, we have line segment AD, very good. So that's the first part of the hypotenuse. And then now it goes on to say, okay, the fourth term is the length of the hypotenuse on the other side of the altitude. So if AD on the left side is the first term, okay, we have our altitude is the geometric mean, which is the second and third term. Now what goes on the fourth term? All right, Joe, follow up, Joe. Good. On the right side, we have line segment DB. And that forms our proportion. So this leads us to Corollary 1 of Theorem 92. So very important. You want to highlight this. You're going to have to understand how to set up these proportions with altitudes. So let's read it together. All right, everybody, read it together, okay? The length of the altitude drawn to the hypotenuse of a right triangle, okay, there we go, is the geometric mean between the lengths of the segments of the hypotenuse. Okay, so the altitude is the geometric mean between the lengths of the segments, all right, so first term, fourth term, all right, of the segments of the hypotenuse, okay? So now, let's go to page number 10, and let's kind of practice this, all right? So we'll do the odds on this page, and then I want you to do the evens for homework, okay? So we're going to do the odds on page number 10, and you're going to do the evens, all right? So let's look at this, okay? So we have here triangle. All right, here's our original triangle here. It's MON, okay? That's our original right triangle here, okay, MON. We are going to draw the altitude. All right, so we're going to draw the altitude to the hypotenuse. Now, how many triangles do we have formed? Preston. Yeah, I got you, Preston. Come on. What three triangles are formed? We have triangle MOP, right triangle. We have triangle OPN, and our original triangle MON. All right, good job. Okay, so now, with that being formed, the directions say name the similar triangles formed by the altitude drawn to the hypotenuse of each triangle. Okay, so here's our original triangle. Triangle MON, okay, is similar to, all right, what other triangle? Based on Theorem 91, okay? So altitude here. So we know once we have an altitude drawn to the hypotenuse, we have three similar triangles formed. So what is the second triangle? Someone give me the second letters for the triangle. All right? So let's go with Emmy. M, what you got? First triangle. So MON is similar to? Good, good, good. So triangle M will make our right angle the vertex angle. So it would be MPO. And triangle MPO would be similar to a third triangle. Chris Rob, what's the third triangle? Try, Chris. Come on, we'll wait for you. All right, good. Good job. So triangle, all right, MON is similar to triangle MPO. And then triangle, third triangle would be triangle OPN. Very good. So, Theorem 91, Corollary Theorem 91, all right, have to deal with the altitude being drawn, okay? All right, any questions? If you have any questions, you could send me a message through your through the Reminder app, or if you want to text me directly, you can do that as well. Now, look at number 7. It says, give the proportion. Now, this is Corollary 1 of Theorem 92. Give the proportion resulting from Corollary 1 and 2. All right, so let me erase my board here. Okay, we have, all right, here's our right triangle here. Okay, we have triangle. All right, let's see here. We have A, B, C, okay? And then we broke C up into 2 segments, right? Here's our altitude. There's our altitude again. So we're going to draw our altitude. Okay, we have a couple various triangles. All right, so we're going to go, this will be Z, and this will be X and Y. Okay? Now, based on Corollary 1 of Theorem 91, let's go back and read it. Theorem 92, excuse me. Let's go back and read it, because this is very important for us to remember going forward. The length of the altitude drawn to the hypotenuse of a right triangle, okay, there we go, it's drawn to the hypotenuse, is the geometric mean. So this altitude is going to be the geometric mean in our proportion between the lengths of the segments of the hypotenuse, okay? So let's set up number 7, okay? So give the proportion resulting from Corollary 1 of Theorem 92. So what would be our second and third term of our proportion? So remember, the second and third term, that's going to be our geometric mean. Now, what's the geometric mean according to Corollary 1 of Theorem 92, class? Right. Very good. It's the altitude. So what letter would represent the altitude? Letter Z. Good. Letter Z. There. There's our geometric mean. Now, what's our first and fourth terms? Our first and fourth terms would be the segments of the hypotenuse. The segments of the hypotenuse, which would be X and Y. Okay? X and Y. So X would be the first term, and then the fourth term would be the letter Y. So, Corollary 1 of Theorem 92, very important, because now we're going to apply this, okay? So let's look at number 9, okay? Everybody follow with me here. Number 9 in your books. Remember, you're going to have to do the evens for homework. So we're at number 9, okay? So we have triangle ACB, okay? ACB, that's our original triangle. So we have our right angle is located at C. When I draw the hypotenuse, or excuse me, forgive me, when I draw the altitude, all right, to the hypotenuse, okay, what happens according to Corollary 1 of Theorem 92? So we have here, okay, right triangle, and we have our segments, okay? Now we call this a D. Now let's set up our proportions. So for every one of these, what's the geometric mean? What's the geometric mean according to Corollary 1 of Theorem 92, class? What is the geometric mean? Gabe, what's the geometric mean, Gabe? Come on. Stop eating that bowl of cereal. I got you. The geometric mean is the altitude. Good job, the altitude. So for number 9, we're going to look at number 9, everybody. Okay, so number 9, we have, if AD is 8, CD is 5. What is the length of BD? All right, now, what's the geometric mean? Okay, our second and third terms of our proportion, we know our geometric mean is the altitude. So 5 is our geometric mean. Now, the first and fourth terms, they are the segments of the hypotenuse. So on the left side, okay, we have segment 8. Segment 8. So segment 8 would be, or AD, right, would be 8. Just dropped my book. Excuse me. And segment, the fourth term of our proportion would be segment BD. All right? Now, since we don't know what that is, we're going to represent that with the letter X, or I'm just going to write segment BD. Now we're going to solve. Remember, how do we solve a proportion? Fausto. Come on, Fausto. All right? Get off your phone. Stop playing around. All right? Lucky you're in school, I can take that off you. Okay. Here we go. The product of the extremes is equal to the product of the means. So let's multiply. So we have 8 times BD would be 8 BD, which is equal to 25. Very good. 5 times 5 would be 25. Divide both sides by 8, and BD is equal to, let me get my my book here. BD is equal to 3.12. 3.12. So the length of BD would be 3.12. Pretty simple. Anybody have any questions? If you have any questions, make sure you email me or get a hold of me in the Remind app. Okay? Now, let's look at number 11. Number 11, if I'm not mistaken here. Okay? So, let's erase our numbers. Okay? All right, number 11. All right, we have BD is 4. We have AD is 6. And we want to solve CD. Okay? We want to solve CD. Now, okay, here's our altitude. Okay? Once we have our altitude drawn, we know our altitude is the geometric mean. Correct, class? Yes, the geometric mean. So if I'm going to set up my proportion for equation 11, proportion 11, we don't know what the geometric mean is, so that's going to be X. Or, again, we'll use the letters to represent the line segment, CD. Now, what's the first and fourth terms of the proportion? Katie Strzelecki. I'm so glad you're bright-eyed and bushy-tailed today, Kate. All right? Now, Kate, what do we have? What are the first and fourth terms of our proportion? According to Corollary 1 of Theorem 92. Come on, Kate, I'll wait here. All right, Kate. Oh, great, great. Class, let's follow up on that answer here. So the first and fourth terms of our proportion would be, very good, segment AD and segment BD. So segment AD would be 6 and segment BD would be 4, okay? Now let's solve. Okay, solve a proportion. The product of the extremes is equal to the product of the means. So 6 times 4 would be 24, okay? And CD times CD would be what, class? CD squared. Good. CD squared. Okay, excellent. Now, CD squared. So now, how do I get rid of the exponent on this equation? Anyone remember how to do that? Good. We got to find the square root of both sides of the equation. So CD squared, the square root of that would be CD. And the square root of 24 would simply be 4.90. 4.90. And so the length of our altitude would be 4.90. All right, any questions so far? Pretty simple. All right, so again, I want you to do page 10. I want you to do the odds. Now, let's go to page 11. Page 11. Corollary 2 of Theorem 92. Corollary 2 of Theorem 92. Now, let's not forget, okay? Corollary, Theorem 92 is talking about the altitude that's drawn to the hypotenuse forms 3 similar triangles. All we're doing now for Corollary 1 and for Corollary 2 is we're showing that, hey, if they're similar, then the corresponding sides must be proportional. So that's all that Corollary 1 and Corollary 2 are talking about. All right, let's look at page 11. Corollary 2 of Theorem 92. Again, you want to know this? I'm going to highlight this and at least understand how to set up the proportion. All right, so let's look at page 11. All right, let's read it together. If the altitude is drawn to the hypotenuse of a right triangle, again, all right, again we have, let me draw another triangle here. Okay. All right, again, we have an altitude here. These are the legs. This is the hypotenuse, all right? So that's the hypotenuse. We have a right triangle here. So we have an altitude drawn to the hypotenuse of a right triangle. Now, sounds familiar, right? That's Theorem 92. Here's another set of proportions that we can make based on this formation. Here it is. The length of each leg. Does anyone remember the characteristics of a right triangle? Right? So the legs are the two ends that are adjacent to the hypotenuse. So the two legs would be A and B. Okay, this is very important. Okay, very important, so listen up here. The length of each leg is the geometric mean between the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to that leg. All right, we're saying, what in the world did you just read, Pastor Dom? All right, I'm glad you asked, because we're going to answer that right now. All right, so here it is. The geometric mean. So again, altitude drawn to the hypotenuse. Now, what's the geometric mean? If I'm going to set up this proportion, okay, the geometric mean is the second and third term. So according to this theorem, all right, corollary of Theorem 92, Corollary 2 of Theorem 92, the length of the legs is the geometric mean. Okay? Length of the legs are the geometric mean. Now, what's the first and fourth term? So, depending on which leg we're looking for, okay? So, we know it's going to be the length of the hypotenuse. All right, so the length of the hypotenuse. So, we would have C, that's the length of the whole hypotenuse, over A, that's the first term. And then the fourth term, you'll see here, right? And the length of the segment of the hypotenuse adjacent to that leg. So whatever leg we're referencing. So again, which segment, X or Y, would be adjacent to leg A? Ah, you forgot what adjacent is. That's one of the highlights I told you to learn from the beginning. What is adjacent? There are two rays that have a common endpoint. Come on. Let's go, guys. Snap out of it. I know you're all in quarantine mode, but this is very important to understand. So, okay, the length of the hypotenuse over the length of the leg adjacent to that side. So we can go, all right, C over A, and now which segment of the hypotenuse is adjacent to A? I'm pointing to it. Yes, good. X would be the fourth term. Now, what if, okay, here's another formulation of it. All right, so if we said again, the length of our legs are the geometric mean, okay? The length of the hypotenuse, all right, the whole length still goes over C, over A. Now, what's the fourth term? Now, let's say we're looking for leg A. What segment is adjacent to leg A? I'm waiting. Right, good, good. It is segment Y. And there are your two proportions based on formulation of Corollary 2 of Theorem 92. All right, so now, I know that means absolutely nothing to you, but let's practice it, okay? Now, before we go on, I want you to look at the bottom of page 11. Here's a couple things I want to read, and then we're going to conclude with page 12 tonight, all right? Conclude with page 12. Look at the proportions formed by Corollary 1 and Corollary 2. These proportions can be used to find an unknown length or an altitude. In Corollary 1, the length of the altitude drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean. Which corollary 2? The length of the sides are the geometric mean. So don't confuse the two. Corollary 1, the length of the altitude is the geometric mean. And corollary 2, it is the length of the legs are the geometric mean. I hope that doesn't confuse you. It's a very important distinction to make between the two. All right, now let's look at, as we conclude this portion, look at number 3 on page 12. Again, we're going to do the odds in class. You are going to do the evens for homework, all right? And I will check to see if you guys are getting your homework done, by the way. Got it? Okay. All right, here we go. Hang with me here. All right, we're coming down to the end. Okay, we have A, B, Z, X, Y, and here is the length of the hypotenuse. Okay, now let's form two proportions based on corollary 2 of Theorem 92. All right, so, okay, what's the geometric mean? What's the geometric mean? Brandon. Yeah, I've been waiting to get you, Brandon. All right, you better stop playing NBA 2K and start paying attention to your math. Nah, I'm only joking. All right, so what's the geometric mean here? Brandon? All right, geometric mean. So the length of the legs are the geometric mean. Very good. So A, B. All right, now, what's number 1 and number 4 in the proportion? So number 1, we have the length of the hypotenuse is the first term. Good. And give me the fourth term. It is one of the segments, and it has to be adjacent to the leg. So we could say X. Very good. X. There's the first formulation. The second formulation, again, would be our legs would be the geometric mean. And how about we have Josh Baruch? What's up, Baruchnikov? Yep. What are you eating? What are you eating during class for, Josh? Didn't you just eat breakfast? Come on, my man. All right, lick your fingers and get this done. Here we go. All right, so Josh, the geometric mean is the length of the leg. So A and B. Josh, what's the first term of the proportion? It's got to be It's got to be the length of the hypotenuse. Good. And then the fourth term has to be the segment that is adjacent to the leg. Very good. So what would be the fourth term? Y. Excellent. All right, they're the two formulations there. So let's do number 5 and number 7, and then we'll conclude for this evening. All right, so this class. Okay, number 5. All right, so here's our triangle here. All right, so our triangle is A, C, B. Here's our right angle. We're going to draw the altitude to the hypotenuse. We're going to call that letter D. Right angle, right angle. Okay? Now, if AB, all right, so the whole length of the hypotenuse is 25, BD equals 16. There's 16. Okay? Now, what is the length of BC? What is the length of BC? Okay, now, corollary 2 of Theorem 92. What do we have here? All right, our proportion. What's our geometric mean? Let's figure that out first. Our geometric mean. What do we have? The geometric mean would be, now what are we looking for? We're looking for the leg. So obviously this is not corollary 2, all right? So this is corollary 1, which means the length of the altitude is, or the length of the leg is our geometric mean. Okay? That's what we're looking for. There's our geometric mean. What's our first term? What's our fourth term? Our first term is the length of the hypotenuse. The whole length. Every one of these are set up the same exact way. The length of the hypotenuse over the length of the leg adjacent to the side. So if this is the adjacent, right? So then it would be BC over 16. BC over 16. So now, if we multiply that, so our product of our extremes is equal to our product of our means. So 25 times 16 would be 400. And BC times BC would be, good, BC squared. Excellent. Now, how do I eliminate the exponent? Draw a radical sign. Very good. Find the square root of both sides. So we eliminate that. So BC is equal to, what is the square root of 400? I'll wait for you to get that up on your calculator. Come on, Gabe. How many times I got to tell you? Hit second. Hit the radical sign. There you go. All right, what's the square root of 400? 20. So the length of BC would be 20. Okay, let's finish with number 7 here. All right, we'll finish with number 7. Okay, so let's erase this. All right, number 7 we have AB is 25. AC is 20. We want to find AD. All right, we want to find AD. Okay, what's our geometric mean? The geometric mean. Very good. It's the length of the leg. So AB, well, let's write our geometric mean first, all right? So I think sometimes that's easier to draw our geometric mean. So the length of our side would simply be 20 and 20. First term, the length of the hypotenuse, which is 25. And then number 4 is the segment that is adjacent to the leg, which would be, we don't know. That we'll call AD. Let's multiply. Product of the extremes, use the product of the means. So 25 AD is equal to 20 times 20 would be 400. 400. We're going to divide both sides by 25 to get AD by itself. So AD equals, what is 400 divided by 25? I'll wait for you to calculate that quickly. Who's got the answer? Call it out. 16. 16 is the correct answer. AD equals 16. Any further questions? All right, so here's what I want you to do for homework. I want you to do your evens on page 10 and on page 12. I want you to fill out your handbook, all right, up to that point. So Corollary 2 of Theorem 92, any definitions need to be filled out. And then I want you to be ready. We're going to take the checkup on Thursday. We're going to take the checkup on Thursday, so be ready for that. All right, guys, I'll check in with you tomorrow. Have a blessed day. Bye-bye.